Alright guys, so this is a video I've been planning to make for a few days, maybe a few weeks now. It's going to be a slight follow-up to the video regarding Intel degradation, but it's going to be a bit more all-encompassing because today I'm going to speak about something that I'm sure a lot of you guys will find interesting, especially those who aren't really overclockers that are watching this. Maybe you're new to PC tuning and it's something that is of interest to you. And that is the topic of headroom. So I'm just gonna say what is headroom. So basically, wait, let me put it in quotation marks because um, it is practically like a, it is a bit of like a I don't know, say a made up concept or maybe not super technically true depending on how you look at it. But um, essentially, what headroom is you have thermal slash power say voltage and temperature allowance slash tolerance that enables you to extract more performance out of a given piece of silicon for a set workload. And that's important because like the concept of headroom is always contingent on what you're actually doing with the part. So I'm sure I'm not sure if anyone else has ever thought about this, but I've thought to myself, what if you run a workload that is so hard to run that like no CPU, GPU, and RAM like combination on Earth can actually run this workload because it's just so damn hard. Like imagine you had a workload that was so difficult that you couldn't even run the workload at stock because at stock, the workload just put so much electrical load on the silicon that you needed more voltage than even the most fail safe kind of VF curve. Like and technically it's possible. So understanding the VF curve. So I'm gonna bring up the picture real quick, and this will give you guys an idea of what I'm talking about. So let's turn this off. So this is my graphics card's VF curve. I've got a 4070 Ti. This is my MSI Afterburner VF curve. Now MSI Afterburner is reading the VF curve from firstly the driver, and secondly the GPU's VBIOS. Because the thing is, um, the VF curve is influenced by GPU boost NVIDIA's algorithm, but it's also influenced by whatever like VBIOS VF curve your manufacturer baked into the GPU, because not all GPUs run at the stock VF curve that NVIDIA set out. NVIDIA's reference VF curve um, changes depending on the model you own, and because not all not all graphics cards run with the same boost clock. So that's interesting. But as you can see, I've got a offset. Now I don't have a curve optimized VF curve because I found that my GPU doesn't run any more stable with the lower or like sorry the higher voltage points set lower than the middle voltage points. I don't find that's indifferent, so I just run a global 180 offset because this GPU can handle a 180 offset. Not that the card's super good or anything. It's just more like the model I have is not an OC model, and it's actually really good silicon from Zotac. So, this model I have can run 180. It runs 180 in this region in most games, and then I found that it doesn't make a difference if I run 180 in like COD and stuff. In this region, COD runs at around 1.15 volts on my GPU. Something like Port Royal would run at like 1.110 volts. Something. FIFA doesn't use the whole GPU, so it sits all the way down here in the bottom areas of the VF curve because there's a frame cap on FIFA. But yeah, anyway, so essentially, like what headroom would be is I've got a VF curve, which is my GPU stock VF curve. Now that might be reference to NVIDIA's. It might just be Zotac's own interpretation of the NVIDIA VF curve, but basically the GPU knows, like the MSI Optimum is reading, and it knows the GPU has these these kind of like vid points where it wants to run certain clock speeds once it's a certain voltage. So at 1000 millivolts, right, the card's going to be running at what? Like, where's the line going? I don't know. Wait, let's follow it. So somewhere a bit over 2600 is somewhere in this region, like maybe 26, I don't know, 2630 or something. Very, very slow for a 40 series card, by the way. But yeah, so at 1000 millivolts, it wants to run at like 2630-ish, maybe, I don't know, whatever, somewhere around there, right? But now, because of my offset, the card is running all the way up at like 2810, right? 2810, because it's a 180 offset, right? So that's essentially what. Why is this possible? Why can my card run? You know why? Okay, so for example, I told you guys card runs at around 1150, right? So the stock would be about let's follow it. Let's follow it. About 2880 maybe. Maybe 2880, possibly. Like I would guess if I had to look at this. Yeah, 2880. So stock would be about 2880 on my card, right? But instead, it's running all the way up here at I want to say this is 3060, I think. But yeah, I can do the math anyway. Yeah, 3060. In practice, it runs at about 3045, 3030 on some maps, but it depends. Obviously, this will go down as well depending on the load of the map. Some maps run at the 1.15 volts, some maps run at 1.14, right? But yeah, so it sits around 3060 in COD and drops down to like 3030 in certain maps, whatever. But yeah, no, why is this possible? So why can this be done? Well, the reason is because my GPU, when I'm playing COD, runs at about 65 degrees. Not even. It runs at like 60 degrees. 65 is like a shit warm day. 60 degrees is more or less where it likes to sit in COD, because COD is a particularly hard game to run. A COD only draws like 220 watts ish. So for that reason, my GPU has a lot of thermal headroom and power headroom. Now you need power headroom, obviously, but all power headroom does is unlock the higher vid points. That's all power headroom does in a GPU context. In a CPU context, in a CPU context, power also unlocks more vid points, but power will also enable you to run more current and then thus run the workload harder. CPUs are weird like that. Like you could, not really. I mean, look, yeah, look. So CPUs work a bit differently. It's a bit more weird with like an Intel CPU or something. But the GPUs basically, if you have a power limit high enough, the GPU will boost all the way towards the end of its vid curve, so as high as it can. I'm actually not totally sure if 20 series, 30 series, and 40 series cards can actually make use of these like higher vid points, because I almost want to say that the max voltage this card will run is like 1.15 volt. I don't even think it runs past 1.15, because I've never ever seen a 40 series card running at like 1.175 volts, 1.2 volts. I've never seen it. I don't think they can. I'm not too sure. I'm pretty sure Nvidia put like a cutoff point at 1.15 driver level or something. But yeah, from what I understand, 1.175, I've never seen it happen. And my 4070, my 4070 I have now, and the 47 I used to own, had a ton of thermal headroom and a ton of power headroom, and they just never allocated. They never made use of. Like, I mean, my card's BIOS limit is what, like, I'll check it. Hold on. So we'll go take a look at GPU-Z. So open up GPU. No. I've got the application. Let's look in my. Where is it now? GPU-Z. So I've got I don't want to update sensors, advanced. Let's go NVIDIA BIOS. So I've got the Zotac BIOS, obviously. Wow, it's quite an old BIOS, 2022. And I've got a 300 watt power maximum on my. It's a single BIOS card, I believe. So I've got a single BIOS. I've got a 300 watt maximum on the BIOS. I've got an adjustment range of 5%. Let's see if that's true. I'm wondering, because I could have sworn it was higher than that. But let's take a look. No, it's right. It's got a 5% adjustment, so I've got 5% to play with. But honestly, like, there's literally no reason that it would even need more, because I've never seen the card run close to 300 watts. In every single game I play, I think it's like 220 to 260, maybe 270 watts. I've never seen higher than 270 watts. And I believe that was like like the Dark Pictures Devil in Me. Where's it now? Which gateway? I can't see it. I think it's in Steam, whatever. So I played Dark Pictures Devil in Me with like ray tracing on, and that might run at 270 watts. But this card has so much headroom, but unfortunately Nvidia set a cutoff point, so the card can't utilize more than 1.15 volts, I believe. Not too sure why. I think maybe it's gonna degrade the silicon. Maybe Intel should take a note of that, because they definitely need some voltage limits. But anyway, yeah. So our Nvidia cards, Nvidia is really careful about not degrading GPUs, and that's why they're the king. Nvidia are the absolute best tech company in the fucking world. I don't want to hear anything about it. Like, Nvidia are the best, bar none. They've got the best drivers. They got the best software. They got the best CEO. He's got the best clothing. You know, he's the best dressed by far. And they sell a premium product. Nvidia stuff is premium. I mean, it's made in China, but it's still premium. I mean, it doesn't matter it's made in China. It's still premium. Like, Nvidia stuff is so well QC'd. It's so well thought out. However, their power connector thing kind of disappoints me. But besides the power connector thing, Nvidia cards are terrific. Like, I mean, Nvidia GPUs really are terrific. And Nvidia's, the way they run their products are the most stable. I mean, compared to AMD, compared to Intel, they're the most reliable products that you can buy. And yeah, and for that reason, even though we have so much power headroom, there's a cutoff point. But either way, it doesn't matter, because in most contexts, we can utilize 1.15 volts. And when you can utilize 1.15 volts, if you have the thermal headroom, so when the GPU die is cold enough, at 1.15 volts, you can extract some performance. Now, if this card is running at near its limit, which is about what, 91 degrees, maybe 88 if you had no offset. So let's say you can lock it at 89 or 91. I don't know what the maximum is. I think it's 91. If this card is running, let's say hypothetically speaking, 88 degrees in load, there's no way I could run a 180 offset. The card is running at 60-ish degrees. That's why I can do offset of 180. At close to its TJ max, which is like 90-ish degrees, it would not be running at a 180 offset. It would be running more like, I don't know, maybe 15 offset, maybe even zero. Maybe zero. Because silicon does not degrade linearly. And I say degrade, I don't mean like degrade like necessarily shaving off. Like, I'm not saying like degrading like what we know of electron migration. I mean like silicon like has a performance fall off, where the warmer it gets on certain silicon, like as it gets warmer and warmer, the power requirements or the voltage requirements to run a certain frequency go up. I want to say exponentially. So like at 90 degrees, the card is a lot less stable than at 60 degrees. It's a lot less stable, like way less stable. So it's not like it's like, oh, 180 down to it gets much more unstable. It gets so much more stable that at 90C you might even see cards crashing at stock. That happens. That really does happen. Some GPUs crash at stock. Some CPUs can crash at stock, depending on the individual piece of silicon. So this is why overclocking is possible. Overclocking is possible because you have a decent enough cooling solution that in the workloads that you main, so let's say it's gaming, in gaming, you have an amount of headroom that enables you to take advantage of that extra, the extra silicon performance. Like, the silicon is much more performant at 60 degrees than at 90. So if you can keep the silicon under 60, you can extract the extra performance, right? Simple, right? Very simple. So, so basically, like, if you go GPUs, let's just say optimal temperature, enough power allowance, and I don't know, let's just say like good quality of silicon. or just say good quality silicon sample. CPUs. Okay, CPUs get tricky because I'm gonna say this: current gen Ryzen Intel chips run very close to maximum at stock, and this is why you have these cases where stock CPUs from Ryzen 7000, Intel 13th gen, 14th gen are so prone to crashing out of the box. That is why. Because the CPUs are run so maxed out of the box that in some cases, when some poor person has a bad piece of silicon, um, even at stock, they might not be doing anything funny. They have crashes. Um, and a good example is Intel, because Ryzen, it happens on, but it's very, very rare. People say it happens on Ryzen. It's very, very rare. Most Ryzen CPUs will benefit from a negative PBO curve optimizer. Because AMD have optimized the PPO algorithm really well in the newest Agisas. Plus, the CPUs just run more stable with the newest Agisas. They've improved the RAM overclocking. They've improved the AMD CPUs right now are very, very refined. They're very, very good compared to Intel. Intel is a bit of a mess right now. So with AMD CPUs, you will benefit from a negative CO offset, and that's going to give you more clock speed. It will. It won't give you a ton of more clock speed. I believe Ryzen 7000 CPUs have a target game clock of like around 5.5 gigahertz ish, at least on the non 3D chips, and yeah, around 5.5 on the non 3D chips, you can maintain with like a negative 20 CO more or less. Like if you can get negative 20 or close to it on all of your cores, you will maintain around 5.5 all core. Now why? How does that work? Well, AMD CPUs are like NVIDIA GPUs. You give them power headroom, you give them thermal headroom, and they will boost up to their max game clock that they can run at. So as long as there's enough power and thermal headroom, they will try and find that vid target to hit their maximum game clock. And like I said, on non-3D chips, it's about 5.5. On 3D chips, it's a bit less. I'm not too sure. I think it's 5, maybe 5.2. I don't know. Yeah, so for Intel CPUs are much trickier right now. And what's the newest one called? There's Raptor Lake and there's... What's the newest one? What is the newest one? Forgot. What's it called? It's a nickname, man. Raptor Refresh. Meteor Lake. Okay, Meteor Lake. Just gotta make sure I put this in capitals so you guys can see it. Yeah. This is non-negotiable. If you have a freaking golden sample, then maybe you have some headroom. Maybe. Maybe. Now, when I say headroom, I mean you're not undervolting these CPUs. You're lucky if they're running good at stock, right? On most BIOSes, because the board vendors have taken it upon themselves. I made this point abundantly clear. The 3900K and the 4900K do not run at stock. They don't run at stock. It's not stock. It isn't. It's not. It never has been. It's not stock. It's not correct. The BIOS is it's wrong. It's false. It's incorrect. Okay. The vid curve is supposed to stop at 5.4 for all core load. On the 3900K, it's meant to stop at 5.6 on the 4900K. And by the way, 5.4 on the 3900K, if you're gonna undervolt that, it's not even like you get a ton of headroom. If the 5.4 vid curve was actually enforced on BIOSes, then the 3900K might have 25 to 30 millivolts, maybe 40 millivolts, maybe 50, even 75 on some golden samples, up to 100, depending on the sample quality. Maybe on mediocre samples, you have maybe 25 to 50 millivolts of headroom. At 5.5 vid point, you have 0. On average samples, 0. And most CPUs are average, by the way. All these SP106 3900Ks, SP110, SP120, that stuff is rare. And for 4900Ks, it's even rarer. If you got a mediocre sample 4900K, you are lucky to run 5.7. You're probably not even running 5.7. It's probably crashing at stock in games. Um, at 5.6, you might have a tiny bit of headroom, but these CPUs have effectively no headroom. I'm gonna say Intel i9 CPUs because the i7s and the i5s have a little bit of headroom because they're clocked so low out of the box. I mean the i7, you guys already know what I'm talking about. But anyway, so yeah, and this is a good cutoff point for this video. So I'll make a follow up regarding RAM ICs and maybe elaborating a bit more on Intel CPUs. But that should be good for this video. It might be like 15, 20 minutes long. So yeah, I will see you guys soon, hopefully with the second part of this video.